we've kind of added, we've subtracted, we've multiplied. We kind of talked a little bit about when we multiply, you add the exponents. Remember we did that once? But now we're going to kind of go through all of the different properties of exponents, of monomials, so that we can really apply those throughout the year. So you guys are going to use these all year long, like almost every essential standard. So pay close attention here. Number one, we're going to start off with a rule. So the rule that I'm going to show you today, or the first one is, we've already learned it. And the way I'm going to write it is b to the m times b to the n. So why do you think I use the letter B? What do you think that stands for? No? The what? So, what do you think B could stand for? It's the base of the exponent. It's the big number, right? An exponent is a number, and then there's like a little one up top, right? That's the exponent. So B stands for the base. And what do you think it means that those are both the letter B? Yeah, it means that they're the same base. So this here means that they have the same base, okay? So the example that I'm going to show you is x to the third times x to the fourth. Notice they're both x's, right? What would happen if one was an x and one was a y? Can I multiply them together? No, they're not like terms, okay? So x to the third times x to the fourth. Now over here, I know it's going to feel crazy to write out. It's going to be like, this is like obvious to me, but I still want you to write it out, okay? So x to the third, what does that mean?
3 x's.
Not 3 x's, it means
X times itself.
x times x times x. X times itself 3 times. Times, what is x to the fourth?
X times
2, 3, 4 of them, right? So x times x times x times x times x times x times x.
4x to the
So therefore, how many x's do we have?
7.
7. So we write that as x to the 7.
Wow.
So this is the one we've already talked about, right? So to put a kind of generic rule that always works, if I have two bases, both to different exponents, what am I going to do to those exponents to get my answer? Yeah, so m plus n. And that's the one we've already learned, so you already got one under your belt. Okay, I'm going to do one more of these real quick. So let's say I have 2 to the third times 2 to the 15th. It doesn't matter if it's an x or if it's a 2 or if it's a y or if it's a 45, whatever the base is, does the base change? No. See how it's b, b, b. So this is going to stay at 2. Sometimes when people start to see numbers, you just start doing things, like a lot of people would put a 4 there. Because they're like, oh, it's 2 times 2, it's 4. No, it's not 2 times 2, it's 2 to the third times 2 to the 15th, which is 2 to the what? 18th. Now, if you really wanted to, you could put that in your calculator, but it's a pretty big number. So we're just going to leave it as 2 to the 18th. Okay? The second rule is b to the m to the n. Some base, whether it be an x or a 2 or a whatever, raised to a power, raised to another power. Okay? So the example that I'm going to give you is x squared to the third power. Now, before I get there, what does it mean to have something to the third power? It doesn't matter what the something is. What does that mean?
Well, it's on itself.
Yeah, whatever's in the parentheses, it could be a dinosaur, or it could be whatever's in there has to be written out 3 times, right? So I'm going to take x squared and I'm going to write it out 3 times. So x squared cubed means x squared times x squared times x squared, right? And now what is x squared? X times x times x times x times x times x. Which gives me x to the, yeah. So yeah, what do you think our rule is going to be? B to the m times n. Because if you think about it, it's kind of telling you how many sets of something there is. So it's telling me I have 3 things of 2, right? So it makes sense to multiply 3 times 2. If I have 3 sets of 2, then it's 3 times 2 is 6, okay? Good. The next one is a b to the m. So now we have different bases. One's an A, one's a B. It could be an X and a Y. It could be a 2 and a 3. And the example that I'm going to give you is xy squared all raised to the third power. So once again, I'm going to kind of go back to step 2. What does anything to the third power mean? Whatever's in there, I need to write it out and multiply it 3 times. So what this actually means is xy squared times xy squared times xy squared. Nope. Only if the y was in parentheses, but the x is also in parentheses. So whatever's in the big parentheses has to be multiplied out 3 times. Okay, now what is y squared? So this is actually x times y times y times x times y times y times x times y times y. So ultimately, how many x's do we have at the end? When x times x is x cubed. Y to the 6th.
That's what I was trying to say. I know they're both cubed.
They're
squared.
They're both cubed, right? So how do you think we should write this rule? What happened to both of the things in here? They both got raised to the third power. So A gets raised to the m, and B gets raised to the m. Now in our example, the y was squared, and then it was cubed. So it's kind of back to step 2 as well. We have to make sure both things get cubed. Okay? Number 4 is b to the m over b to the n. Now we're going to have a fraction. B to the m over b to the n.
I know this works.
So the example that I'm going to give you is x to the 7th over x to the 4th. Now, once again, you have to understand what that's asking me to do. So x to the 7th is 1, 2, 3, 4, 5, 6, 7 x's all over. 1, 2, 3, 4. Okay, what's 5 divided by 5? What's 20 divided by 20? What's 4 million divided by 4 million? What's x divided by x? What's y divided by y? What's z divided by z? Yeah, anytime you have something multiplied on top that's also multiplied on bottom, it cancels out to 1. So x divided by x is 1. 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 So how many x's did not cancel? 3 of them. So therefore, my answer is x to the 3rd. So look back at our kind of generic rule that applies to all scenarios. What happens to the exponent on top and the exponent on bottom? Yeah, we subtract them. So we'll rewrite this as b to the m minus n. How many of you already knew that? Yeah. Now, real quick, I want to show you one more. Sometimes it's kind of, I'll come back to this, just watch. Sometimes it's kind of weird when there's more on bottom. Because if I subtract them, what am I going to get? A negative number. What's 4 minus 7? Negative 3. And we're actually going to learn what that means here in a second. But for now, that's kind of confusing, right? X to the negative 3rd power, like, what does that even mean? Okay? So I would think of it a different way. I like to think of it as kind of like top heavy or bottom heavy. So x to the 4th is x times x times x. This time, more of them are on bottom, right? So I would consider this a denominator heavy fraction. So once again, 2, 3, 4, 5, 6, 7. How many cancel? 4 again, right? Same 4, so 1, 2, 3, 4. But where is the remainder of them this time? There's more on the bottom. So it's 1 over x to the 3rd. Does that make sense? So now you might be able to figure out what the negative exponent does. Keep that in mind. Lock it in your little brain. We'll come back to that in just a second. Okay, a couple more. Number 5 is when we have numerous things, different bases. So this time we have a and b both raised to the m power. You can probably guess what's going to happen because it's very similar to number 3. What do you think is going to happen to a and b?
Both gonna be
Exactly. They both have to be raised to the same power. So a over b to the m is actually a to the m and b to the m. So we get, so let's do this one here. X over y squared all cubed. Now, if we wanted to, we could write this all out, and I know you want to. X over y squared times x over y squared times. See how laggy my TV's doing? Now, when we multiply straight across, on the top, what's x times x times x? X cubed. And what's y squared times y squared times y squared? Y to the 6th. So that would be our answer, x cubed over y to the 6th. So they both got cubed. The x is just straight up cubed, and the y was already squared, so then we squared the cube, or we cubed the square, and we multiplied, so that was kind of back to step 2 again. We have to multiply those exponents. Okay, now the last two are the easy ones. They're easy to remember. Okay? This one is b to the 0 power. Get out your yellow calculator, turn it on, and do 5 to the 0 power. So 5 caret 0. Then do 10 caret 0. And then do 17 caret 0. And then do 4,721 to the 0. And then do 5,432,675,821 to the 0 power. What's the answer?
1.
It's 1. Now, do 0 to the 0th power.
And create a black hole.
It creates a black hole, we'll just get sucked into the calculator.
It's an error.
Yeah, it's an error. Now, I've actually looked on Google before, and there are numerous, legit websites that actually say it's 1. Your calculator gives you an error. Some mathematicians say it's undefined because it doesn't make sense, right? If you have 0 something, and you take it to the 0th power, why would you suddenly have 1 of something? It doesn't make a lot of sense, okay? But just kind of know, you're not going to be quizzed over that or anything. Some people say it's 1, some people say it's undefined. It's kind of a weird scenario, so. But for the most part, anything to the 0th power is 1. So, what is 10,000 to the 0th power? 1. Is, how do I write this? B to the negative n. So it's a base to a negative number. So in your calculator, I want you to try 2 things. Do this with me. Do 2 to the negative 1st power. And then turn that into a fraction. Do you remember how to do that? Nope. Turn it into a fraction is math 1. Hit enter. And then hit math 1. Okay, let's do another one. I want you to find a pattern here. Now I want you to do 3 to the negative 1st power. And then turn it back into a fraction. So 3 to the negative 1st power. Hit enter, and then hit math. Enter, enter. What happens?
The 1 goes up top. And
1
then
over
it's
3.
operated, and then
One more. So let's do 4 to the negative 1st power. 4 caret negative 1, enter. Math, enter, enter. What do you get? So if you had to guess, what do you think 5 to the negative 1st power is? 1/5. Okay, so what happens to the number on top?
it goes up over the.
It goes under 1. So b over in positive.
I knew